So we're going to go through and talk about monitoring and troubleshooting of BGP here. And some of the, I want to think of some of the most common type of situations of what we're going to be doing for troubleshooting. Now, typically what we're going to discuss here is going to be about the idea of troubleshooting a neighbor relationship. How come this neighbor is not coming up, or I'm not receiving routes from the neighbor, or I'm not sending routes outbound to that neighbor? So we're going to see a lot of different things we can actually verify here. First off, one command, the show IP BGP summary command. This command is good because it shows us information about what neighbors have I configured. So it shows you the IP address that you've configured, what autonomous system number I have configured that neighbor to be into, not necessarily saying that neighbor is in that autonomous system, it's just what I've got them configured to be a part of. Right? We want to see that we are receiving and sending messages outbound to that neighbor. BGP, when it updates neighbors, it uses this concept of a table version, okay? What you'll see when you do this command right here, notice right here, the table version is the local routers table version. We have the main table version that we should have for all of our neighbors. And then down here, we get to see what has that neighbor been updated to, okay? So we see this second neighbor has been updated at table version number 10, meaning all changes have been sent outbound to that neighbor. Notice how this other neighbor is at table version number 1. What we're going to have to do is to send them all the updates that have changed between table version number 1 and table version number 10. Okay. We should see then the idea of how long we have become neighbors, in this case, 54 minutes and 24 seconds. And I see that I've actually received 9 prefixes from this neighbor as well. Right? So this bottom neighbor is an established neighbor. We've actually shared routing information, become neighbors back and forth. Notice how the top neighbor, right here where it has the up-down status, shows that we've never become neighbors. And the BGP state is we are idle at this point in time, not being neighbors whatsoever. Okay. So we're going to look into why are we not becoming neighbors with this guy 172.16.12.11 that we're looking at. By the way, just to let you guys know, you got your input queue and output queue. If your input queue is above 0 more often than not, typically tells me I'm low on CPU utilization, okay? Meaning they've sent me an update and I can't process it quick enough is really what's going on with them there. If you see your output queue above 0 quite often, typically tells me I'm low on bandwidth and I can't send out an update to that neighbor, okay? So it just gives you kind of an idea of what you want to look for on those interfaces there if those numbers are above 0. Now you can also get more detailed information about an individual neighbor by going through and doing a show IP BGP neighbors and then specifying the IP address of the neighbor. Here they're specifically looking for that 172.16.12.11 neighbor. I want to see a few different things here. First off, notice that this is an established connection. Okay, that means that we've actually shared BGP routing information. I see right here that it is an external link, so it's an external BGP neighbor. Should see that we have an active neighbor relationship with them. This neighbor capabilities here, these are the capabilities that the neighbor actually supports within BGP within here. One of the things we're looking for is this route refresh being advertised and received. That tells me that we can go through and say, without having to drop our neighbor relationship, that we can resend routing updates whenever we need to in either directions, okay? You'll see when we make changes to BGP, remember that as we become neighbors, we share all routing information. After that, only changes in topology will I send you an update. So if I change, let's say, my outbound policy of what I'm going to send to you or what I want to change in, say, a route map, for instance, I go through and set it all up. It does not immediately make changes to what's going on within my neighbor's BGP table until I resend them all my routing updates. So a lot of times what we're going to do within here is to say, let's clear that BGP neighbor and then do an out at that point, at the end of that command that says, force my local router to resend all my routing updates outbound to my neighbor. going through those new policies as an outbound policy. Likewise, we can clear a neighbor in as well. I'm going to send a message to my neighbor, what they call a route refresh message, asking my neighbor to resend all of his routing updates back to me because I've changed my inbound policy from that neighbor. Notice we get to see our keep alive, the default 60 seconds to an external neighbor, and my hold down time is 180 seconds. 3 times that keep alive interval. Looking at the BGP table, show IP BGP. And again, we get to see all the different attributes of a lot of these different routes within here. Right? What the actual prefix is, who the next hop is. Okay, that's again the next hop external BGP router. The MED, which we call the metric in the BGP table, our local preference. Right? None of these routes have a local preference. It's because all my neighbors are external neighbors in this case. Remember, local preference is only sent to an internal neighbor. So I'm not receiving these routes from an internal neighbor. We have the weight, in this case 0 for all of these individual routes, which is the default weight for anything that is learned from a neighbor. We have the autonomous system path. Some of these guys just have to go into one autonomous system, where this route I have to go through 2 different autonomous systems to reach the one network. And then last but not least, this is the origin code on this side over here, okay? So this is telling me that somebody uses the network command to advertise these routes into the BGP table to begin with. And note that they give you kind of a key up over here. If you should ever see anything like an S or an R within over here, right? A lowercase r tells me it's a routing information-based failure, right? Remember, we mentioned, I don't know if you guys were here earlier, we need to have a route on how to reach a network before I can advertise that out in the BGP, okay? The whole idea is that I don't want to advertise out onto the internet something I can't actually reach in my own network, okay? So they call that BGP synchronization. And if a route is not synchronized, you would see that RIP failure. Some good things to be looking for in that BGP table. Now, you can get much more detailed information about an individual route by going through and saying, show IP BGP, and then specify the prefix we're looking for, or destination IP address for that matter. It would show you which route are we going to use to get to that destination address, okay? So here they're looking at show IP BGP for the 1.0.0.1 address. How would I get to the 1001 address? And they show me in this case right here, my BGP table, I've run a route for the 1.0.0.0/24 network. There are 2 available paths, right? So we get to see those 2 available paths. And they show each one of these paths as well. So here's the first route that we have. Here's the second route that we've got. And they get to see the next hop address of the route, who we learned it from. So this is the neighbor that we learned it from, and their actual IP address on their interface. So this is the router ID. This is their interface IP address. The origin, so that's showing me it's an IGP. The MED, the local preference. We said it had to be valid. We have to be able to reach the next hop IP address of the router. It is learned via an external neighbor, and this is considered to be my best route to reach that network. And then we see the bottom route over here, different route, but in this case, notice 2 different autonomous system numbers to go through versus the top one where we only have 1 AS number to go to get to that particular destination network, and why it's chosen as the best route as well. So some real good things, especially when we are becoming neighbors, that we can look at that are debug commands. You can do a debug IP TCP transactions. And this should show me that TCP conversation. Now, be careful, because remember, when you're doing debugging and you've said debug IP TCP transactions, there's nothing in that command that says, I only want to look at BGP information, okay? That will show you about every TCP conversation going through the router, in and out any individual interface. So rather than this, think about creating an access list that matches any source to any destination on destination port 179 for TCP. and matching any source on source port number 179 to any destination. And then in your debug, you can say debug IP TCP transactions list, and then specify the name or number of your access list. Now it only debugs things that are matching that access list, okay? Much better for both memory, CPU utilization, and being able to read it, right? What it is we're really looking for. And you can also do a debug IP BGP events. We'll show you things like neighbors changing state, updates that are being sent back and forth. Do they ask us for a route refresh or not? Right? So you get to see a lot of good information within there by utilizing that BGP events debugging. We can debug BGP keep alives. We can debug just updates, okay? Only when there's a change in topology am I going to send that out, or when we first become neighbors and send out every single update we have. Now, again, I mentioned use any of these debug commands with caution because, again, they don't necessarily only debug IP. Now, these right here, where you're debugging specifically IP BGP keep alives, well, that's going to be a BGP command and only going to be looking at BGP information at that point. And so like we mentioned, we can go through and match an access list on the end of these guys. So we'll go through and say, hey, I only want to debug information that matches this particular access list. So we're going to discuss a few different problems within here, okay? Common problems for that neighbor coming up or BGP peering coming up. First up, we'll see the BGP neighbors don't become active. They remain idle the entire time, okay? We might also see a neighbor that goes to the active state, but it never gets to the established state. And then finally, we'll discuss the idea of a neighbor oscillating between idle and active and idle and active and idle and active over and over and over again. And how can we troubleshoot these? These are all symptoms that kind of tell me what's going on within that BGP neighbor relationship. And really, most of it's going to be due to the idea that I've configured it incorrectly, okay? But remember, when we're talking about configuration, I configure my side, the service provider's configuring the other side, right? So we really need to know what they're doing and where they're sending information for us to be able to configure BGP correctly. So a lot of information that we want to look for. So here's the first symptom. BGP neighbors do not ever become active. They stay in the idle state. When you do that show IP BGP neighbors or the show IP BGP summary command, you should be able to see the state of that neighbor's relationship as being idle all the time. Typically what this means, as I'm idle, the neighbor cannot be reached, okay? They show that the neighbor's not directly connected. That would be true in an eBGP session. We said last hour that we were here, that normally eBGP peers are directly connected, okay? When it is idle, what it's telling me is I don't have a route on how to reach the neighbor's IP address. So I can't send a TCP session out onto that neighbor, okay? Even the original TCP SYN. So you can verify that with a show IP route. Verify that we do indeed have a route to reach the neighbor's IP address that we've configured in BGP. Now, again, think about the idea of making it a little easier on it. Show IP route and then specify the neighbor's IP address at that point, right? Verify we've got a route to be able to reach that neighbor. If I don't have a way to reach their IP address, obviously I'm not going to be able to send a TCP connection to them. So here's a different symptom. The neighbor is active, but it never becomes established, okay? So we want to take a look at a few different things within here. They show, first off, debug IP TCP transaction displays that we receive, the TCP SYN is not being answered with a SYNAC, okay? I'm sending out a TCP SYN, never get any kind of an acknowledgement in the other direction. They show, in this case, it's the neighbor is not reachable. I've got a route in the routing table that tells me I should be able to reach that neighbor, but the neighbor's not answering anything, okay? So they show, again, you can verify connectivity with that neighbor with a ping. Make sure that the source IP address is the same source IP address you use in your BGP updates, okay? Check to see if you've got some kind of access list. Now, I want to make sure you guys realize this as well. When it comes to access lists and any kind of routing protocol, doesn't matter whether it's OSPF or EIGRP or BGP. Let's say I've got router A over here, router B over here, okay? And they've got a link in between the two. If router A has an outbound access list. All right, so an access list as it goes out of this interface. Any of those routing updates that we send in outbound, OSPF or EIGRP or BGP, because it comes from the router, would skip over this access list with no problems, okay? They don't even get checked by that outbound access list. Access lists are only for traffic that go through the router, okay? So in this case, it's coming from router A. It would skip over that access list without any issues. However, an inbound access list over here on router B could most definitely block BGP updates, okay? So that inbound access list has to allow BGP traffic. It's TCP port number 179. And you want to make sure that you allow both source port 179 and destination port 179, okay? So make sure you're allowing both of those as it comes through that access list. Okay. Again, you can do that, check for the presence of an access list. I've been doing a show IP interface and whatever the interface name is. And they're kind of showing right here that whole idea of looking at that debug. So they've done a debug IP TCP transactions. And notice right here, they're showing we are sending a sequence number outbound. We're trying to create a connection to my neighbor on port number 179. Notice my TCP conversation went from a closed conversation to a send. And then nothing comes through. And all of a sudden it goes from send to closed. It timed out and we never received a SYNAC, okay? Notice eventually then that TCP block is destroyed at this point in time. They're saying we could not start that TCP conversation. No three-way handshake ever took place, okay? So again, I'm sending out the SYN, but never receiving anything in the other direction. That just tells me that that neighbor is not reachable. I have a route to reach it, so I know what interface I should get and use, but that neighbor is not responding at all. Almost like their interface is turned off or shut down. We receive the neighbor is active, but the session never goes to establish. Same symptom, okay? And we're gonna look at these guys, and again, notice that when we do a debug IP TCP transactions, it's gonna show us when we send out a TCP SYN, now all of a sudden it's being answered back, but it's being answered back with a reset message, which resets the TCP conversation all over again, okay? What that tells me is that I have them configured as a neighbor, but they don't have me configured as a neighbor, okay? Or if they do, they're using the wrong IP address. What happens in this case? When I send out this TCP SYN on port number 179, they're looking at the source IP address of that SYN and saying, is that a neighbor that we've got configured in BGP? And if it's not, I immediately send you a reset. You're no neighbor of mine. Don't even try and create a connection on TCP port number 179, okay? So verify what they've got for that neighbor relationship. On both routers, do a show IP BGP summary, okay? Make sure that they've A, got me configured as a neighbor, and B, that the IP address that they're using is the correct IP address. And again, they're looking at that. Here's that debug command right here, debug TCP IP transactions. And we're saying, I'm sending a TCP SYN right here. It went from close to a SYN sent. Notice it went from SYN set to close almost immediately. Why? Because the remote sent a reset. And then we destroy that TCP block again. Okay, so this isn't going to take nearly as long as what we saw before, where it took almost 2 minutes for that to time out. They never sent me a SYNAC. Now I send out a SYN and they immediately respond back with a reset message. Okay, so you can quite easily tell when you're doing that debug. If it takes a long time and then it closes out, never receiving any traffic back, that's because that neighbor's not there. Okay, versus them immediately sending a reset message. I'm not configured as a neighbor for that particular BGP peer. Like I said, we have to check either the address or do they just not have any neighbor relationship configured for me just yet, okay? And then we can have the issue of a neighbor going through and oscillating between active and idle and active and idle and active and idle, okay? Remember, idle is where I'm looking to see, do I have a route to reach that network? Active means I'm sending a TCP connection to try and receive information from that neighbor, okay? And what you're gonna see here, the debug TCP transactions shows that the TCP session is established. So they get through the whole three-way handshake and then it's torn down immediately. Well, this almost always tells me there's an AS number mismatch, okay? Remember, I have to go through and say neighbor and their IP address remote-AS and what AS number they're in. So if I've got, let's say over here, I've got this router. Let's say its IP address is 1.1.1.1, and this is 2.2.2.2 over on the other end, okay? Connected back and forth between the two. Let's say I'm in autonomous 65,000. If I'm router number 2 over there, they've set up their neighbor relationship with 1.1.1.1, and then they say remote-AS 65001, for instance, okay? They've got me configured in the wrong autonomous system number. What you're gonna see happening here, as I send a TCP SYN, they're gonna say, is 1.1.1.1 set up as a neighbor? Yes, they are, okay? So I'll send back a SYNAC. They'll send me back a final acknowledgement, completing that TCP three-way handshake. And after that, then you're gonna see that I'm gonna send what we call a BGP open message. And in that open message is telling my neighbor, essentially, what do I support as far as capabilities of this device in BGP? It also includes what I've got for my autonomous system number. And if that AS number does not match what they've got configured, you're gonna see BGP sends out what they call a BGP notification message, okay? So you can actually look at BGP events as well. If I do not only debug IP TCP transactions, but debug IP BGP events, you'll see that notification message being sent out on as well, okay? And again, they show, verify those AS numbers are configured correctly for your neighbors using the show IP BGP summary command on both ends, on both routers, okay? And they're gonna show you these debugs here in just a second. All right, so notice I've got, again, debugging for both TCP transactions and for BGP events are enabled up here, okay? They kind of skip a lot, but I see that I'm sending a TCP SYN. I then receive the acknowledgement in the other direction. A SYN was received. Notice it goes to an established state for that TCP conversation. Then we send a BGP message. And I get this guy right here, BGP notification, okay? Anytime you receive a BGP notification, it resets a neighbor relationship. But it even tells me why they're sending this BGP notification. I'm sending off to my neighbor because the peer is in the wrong autonomous system number, okay? And then notice we close out the TCP. So I send a FIN, they send a FINAC, I send a final acknowledgement, and it closes that TCP session. So I'm actually doing a full three-way handshake and then getting a BGP notification message. And that's why you want to be able to look at these BGP events for your debugging to see this notification message. It's a quite common misconfiguration. Okay. So it gives you a lot of good information about what we should do for troubleshooting of that BGP neighbor peering. I would also give you one other thing as well, and I don't know if they actually even show it. Let me just take a look at it. They give you a command here. When you look at this, show IP BGP neighbors and the IP address of your BGP neighbor. This is not all of what you're displayed here, okay? There's a whole bunch of stuff that they omitted in this slide. Take a look down at the bottom of this because it'll give you information about how many routes did the neighbor actually send to us, and did we filter out any of those routes using an access list or an AS path access list or a prefix list or a route map? Are any of those routes actually suppressed due to one of those filtering capabilities that we have available for us in BGP? Okay, so that's good information as well. I would also say another good one, you can go through and do a show IP BGP neighbor and the IP address of that neighbor, received routes, okay? Or just the keyword routes. and I can also say advertised routes, okay? So the keyword received routes on that is only in an environment where you've actually got what they call BGP soft reconfiguration turned on, okay? What happens is when they send you an update, you keep a list of all of their updates without ever going through any of our inbound filters. And then we run all of that unfiltered list through all of our filters to determine what's in the BGP table. So when I go through and do a show IP BGP neighbors and their IP address, receive dash routes, it says, let me look at that unfiltered list of the routing information that they originally sent to me before it went through any prefix list, okay? If I do a show IP BGP neighbor and their IP address routes, it shows me which of their routes actually ended up in my BGP table. So after going through all my inbound filters, which of the routes were learned from this neighbor that were put in my BGP table, okay? And last but not least, the keyword advertised routes. This shows me that the routes that I'm sending outbound to that neighbor that have made it through all of my outbound filtering, okay? So it's good to know what am I actually trying to send to these neighbors within here. We mentioned the idea that if I use the keyword network and I put in a network statement and then mask and I use a subnet mask, I need an exact matching route in the routing table. Well, that advertised route command would show you. You're not even trying to advertise that network outbound. Okay, gives you kind of an idea. Hey, maybe we don't have an exact matching route in the routing table. Okay, so some good things that you might want to look into at that point in time. And I know that's kind of quick, but that's kind of really what I have for you guys for this particular session, unless anybody has any questions.
Yeah, one quick question.
Go for it.
Yeah, so if you look at a show TCP brief,
Yep.
and you always see the BGP has a outgoing port of 179, but on the inbound or coming back, you'll see a higher port than 10,000. Why is that? I could never really find documentation explaining why that is.
So here's what's going to happen. When you've got, again, let's call it router A and router B out over here, okay? And they set up a BGP neighbor peering session. I connect to TCP port number 179 as the destination port. That is the well-known port saying, this is a BGP session. I want to communicate with your BGP process. The source port number for that connection, however, is one of those ephemeral ports, something above port number 1025, okay? So they just randomly generate any source port number they want for that particular conversation, okay? So that's where you might see it be like a 10,000 as your source port number, because it's just randomly generated. Now, router B is also going to try and connect and send a TCP conversation to us in BGP. So this will be to destination port number 179, and they'll have their random port number, like 20,010, for instance, okay? So that source port number is just one of those ephemeral ports. And it's just like any other conversation in TCP. You think about an HTTP session. I'm connecting to TCP port 80 because it's web traffic, but my source port number is just a randomly generated port number above port number 1025. Okay? And it's one of the reasons why I said when you want to match BGP, you want to match information coming to my destination port number 179 and the source port number 179 as well, right? I need to be able to match both of those sessions so it can be allowed through my connection. Now, they're going to start two different BGP or TCP sessions when they first become neighbors. They don't need both of these TCP sessions. So once they realize that these are both the two neighbors, it's just the two routers talking, they will drop the TCP session from one of the routers that has the lowest router ID in BGP, okay? And you get to see right here the router ID that you've got for that neighbor. All right, well, that's all I have for you guys. So thank you guys for coming for another Tech Talk with me today. It's been a pleasure having everybody here. And again, if there's anything I can help you guys out with, might as well throw this out here. My name is Russell Hughes. I know some of you guys have already met me, like PJ. Now my email address is rhughes at Sunset Learning, sorry about that, .com. So feel free to send me an email if you have any questions later on as well, all right? I'll do my best to get back to you guys as fast as I possibly can. But that is what I've got for you. So thanks again.